Hello learners, welcome again to the course. In the previous lecture, we have discussed about a case study in which we map the scientific productivity of a domain. We have considered the example of an application of AI in tourism where we extracted the data from Scopus based on certain conditions. These conditions were like year, language of the documents, publication stage and the document types. And finally, we have downloaded the data in the CSV format. After downloading the data, we have analyzed it in R and we have done like annual productivity distribution of publication, citations. We have visualized the year-wise publication in the line plot. Then we have also seen how we can beautify the graph. We have discussed about the prolific sources and we have seen how we can have top 10 sources or the sources based on the conditions like we have 100 or more publications. Then we have discussed about the authorship analysis, how we can count the number of authors with the help of pattern matching. We have visualized the authorship analysis in the stacked bar plot. Finally, we have discussed about the identification of the core sources using the Bradford law. So to do that, we have taken up the code from the bibliometrics GitHub page, and after changing the column name of our data set, we have run the code to get the results of core sources as per Bradford law. So in this particular lecture, we will be discussing about the case study on an author. We will be doing some analysis on the publication of an individual scientist. For this example, we will take the scholarly data of Professor Vijay Ketan Panigri, who is professor at Department of Electrical Engineering at IIT Delhi. So in the literature, the research assessment of a scientist is commonly known as scientometric portrait. It was first coined by Kalyani and Kalyani in the year 1993, who conducted a scientometric portrait of Vinodini Reddy, who was the director of National Institution of Nutrition, Hyderabad. Some other researcher gave the term like biobibliometrics, but it did not get popularized, and the term scientometric portrait is commonly used for such kind of analysis. So, scientometric portrait is conducted to recognize the prominent scholars, inspire others, and guide those who dedicated their life to scientific advancement. So, generally, the following information and points are to be included in the scientometric portrait of an author. This information guide is created by these three authors. So, in this, first we have a bibliographical sketch that includes the date of birth, place of birth, family, and secondary education. After that, in education, we have information like where the author have completed undergraduate, postgraduate, and PhD, or maybe the PDF, and the main research area of PhD and PDF, and under whom the PhD and PDF is conducted, who are the supervisor, advisor, and role models. Then, what all the places the author have worked, position held, membership in the organization, author responsibility like editorial, peer reviewer, and engagement with the industry. What are the hobbies of the author? What all places the author have traveled and all. So in research output, we would like to see about the type of document published like journal articles, conference paper, book chapter, letters, book review, editorial notes, books, monograph, etc. Then number of publication, research productivity throughout the year, expertise area and all. And in research impact, we understand the impact of the research like citation, H index, G index, and in collaboration, we map the degree of collaboration, who are the major research collaborators, and looking collaboration location wise, maybe the affiliation wise, and so on. And in authorship pattern, we do the analysis of number of single author document and multi-author document. Inside the multi-author document, whatever the order of authorship, whether the author was in the first author or the second author or third author, then what all the authors have contributed to teaching, like the course taught or developed, number of students that have been supervised by the authors, and the topic of the dissertation and the thesis, and in the final, the different award recognition received by the authors. But in this particular study, we will be focusing on doing the analysis of research output and research impact of Professor Vijay Kant Panigri of IIT Delhi. So to do that, we need to follow the same step what we have followed for doing the analysis of mapping of research of AI in tourism. Generally, while doing these kind of analysis of an author, no or minimum filters are to be used during the data extraction. As you see in the previous, like when we were discussed about mapping of AI in tourism, we have done the lot many filtration like those language wise or year wise, but here our aim is to portray what all documents have been published by the author. We won't be using any of the filters. Then here selection of terms are not there, but we have to search the database with the name of the author or the author id or the scopus id. Let us first search the database and extract the publication data of the professor. So this is an interface of Scopus. On this, we'll go to the tab authors, and here we will write the name of our professor. So it retrieved me this profile, and there is only one single result with this name, and this is the only author, and these are the number of publications. So we can click on these 805 publication, and then we can extract the data. Just click in here, click on export, then CSV format. So apart from this, we can also retrieve the result based on either by using the ORCID ID or maybe this author ID. And just if we like say for example, we remove this name and we will give just author ID. Okay. Okay. So the same number of documents have been retrieved. So our this file is downloaded. This file is showing that Scopus 1 because I already have the earlier Scopus file which I have done for the previous lecture, but we will change this name to this file name to Scopus BK Pani. Okay. After changing the name, we'll move this file to the document directory because many of the times like whenever you will be using R, the default directory will be the documents. Okay, unless you have changed it. Okay. So if you haven't changed the directory, you move this file to the document directory. So and also open your R Studio. After opening, the first thing we'll do the checking of our current working directory. So if I do like this, I'll get the results. My current directory is non document. So I'll keep the file this Scopus BK Pani into our document directory, or I can give the full path here, or I can change the current directory through downloads. I'm not changing the directory and I'm keeping the this whole file to the document directory. Okay. So next, what we have to do? We have to import the data. So how we will import? We'll just write the name of the file. So there are like these are the 4 file. I'll just select this file and that's it. So my data is imported. So now what all analysis we will be doing on this data? So on this data we can do multiple analysis. Some of the analysis are listed here. So the annual productivity of an author, we can do that, but we have already discussed about how we can calculate the annual productivity in the previous lecture. So I request you that based on that you give a try on finding the annual productivity of the professor. Then the type of work published we'll do in this lecture because we haven't discussed in the previous lecture. Then authorship analysis, the authorship analysis we have discussed in the previous lecture, and similarly you can also identify that what all documents of the professors are the single authored publication and what are the documents are the multi-authored publication, and inside those documents if there are multi-authored documents are there, what exactly the position of that author. Okay, whether the author is in the first author, second author or third author. Okay, so we can do that with the help of pattern matching. Then high cited publication and key topic of research. So among these 5 analyses, I will be discussing only 3 in this case study. So I will discuss about the type of work published by the professor, then the highly cited publication and the key topic of research using the topic modeling approach. Okay. Other those 2 analyses, you can just follow the what I have discussed in the previous lecture and you can easily find out. Okay. But if you face any of the issue, please let us know in the discussion forum. So our data is imported. So here our object name is df case 2 because our data is imported in this. So this you need to remember what exactly your object name where you have imported the data, because in the previous lecture when I discussed about the case study of AI in tourism, the object name was df case, okay, but now I am naming it df case 2. So it totally depends on you if you want to give any other name to this object, okay. So what the first thing we will do after importing the data, let us first view the data set, how is that data is. So what function we'll use? We'll use the view function. We'll call this, and this is our whole data. And if you see here, this is 805 publications. Then we'll do the summary of this data set. And if we see the output of this summary, all those things are available. Next, this year-wise productivity of publication, you do as your practice, and please let us know in the discussion forum if you face any of the issue. Now we will move to the second part where we will be discussing that what type of document are published by the author, okay. What we have to do that, what we need is our column name in a data set. How to check the column name in the data set? Using either the dollar, or we can go to this part here, and then we can see that where is the document type column is there. So this is the document type column is there, or we can use the col names also. So this is our exactly the column where our document type data is there. So if I like do like this, automatically it will show us that there are two columns are there that start with D, but we are focused on this. So only one column is there with document type, okay. Now what function we will use to count the occurrence, like the number of occurrence of articles, number of occurrence of conference paper, or maybe the book review. So the one function we have used most of the time for counting the occurrence, what that function is? Table function. We will use the table function. So if we do like this, so it gives us the result that the professor has published 395 articles, 15 book chapter, 363 conference paper, 26 editorial, and 6 review, okay. Will assign to a object, and now we can see this object, okay. We can easily see that article 395 in a tabular form, what output we have seen here. Now we want to add one extra column to this object, okay. So we want to add one extra column to this data set. So our existing data set have the category of publication, then the count of the publication. Now we want to add an extra column where we will have the percentage of the categories, okay. So what percentage of publications are article, what percentage of documents are conference paper, okay. So how we will do that? The simple calculation. So we will call the frequency divided by sum of the frequency, multiply by 100. So if we do like this, and as I discussed in the previous lecture, that we don't have to call this view function again and again, it will be automatically updated. So let's see here. So it is automatically updated here. So we can round it off to 2 decimal places, or maybe 3, whatever the places you want. So I am transforming this to 2 places only. So this is my third column where I have percentage up to 2 decimal places, okay. Now if you see here, this data is not ordered, okay. It is ordered in some sense, like if you see here, the pattern is that A, B, C, E, R. So it is maybe alphabetically ordered, okay. But we want to order this data set in terms of the number of publications, okay, in that particular category. So how you will do that? we have already ordered this kind of thing in the previous lectures. So if I do like this, so it is ordered our data set. But if you notice here that by default it is ordered in the ascending order. Okay, so the started with the minimum and goes to the maximum. So the default value of this particular function is arranging in the ascending order, but we want to arrange in the descending order. So how we will do that? So we will add one extra argument here, that decreasing equal to true. We want to do it in decreasing order. So if we do like this, in decreasing order, our data set has been arranged. We'll arrange this data set in decreasing order and assign to our existing this object. Now if we see here, it is changed. So from here we can easily infer that the professor has published almost half of the publication as articles, okay, followed by conference paper, and very minimal number of documents are editorial, book chapter and review. Okay, so this is done. Now we can save this whole analysis to our external file. How we will do that? We'll save it as like CSV file. Then we'll call this function write.csv. We'll give our object name and the file name what we want to export it as. Okay. So here this is our data set and we want to save it as doctype.csv. Okay. Now, as I discussed in the previous lecture also, I have given the emphasis on more of the visualization, okay, because this is a tabular data, but if we show some visualization, it will be more understandable, okay. So what we will do, we'll make some graph out of this data. So what kind of graph we can make? So one possible graph I can think of is that pie chart, because in pie chart we can show that this much area has been published as article and this much area is a conference paper, okay. That clearly visualize that major area is related to article and conference paper. I'll generate pie chart. As I discussed earlier also, that many of the function names are related to the task what we want to do. So for creating a pie chart, we have a function called pie, and before using any of the function, what we do, we just check with a question mark that how we have to call this pie chart function, then what are values we require. So if I do like this, and if you see here on this side, all things are given, okay, how you have to call, what are the arguments are there, okay. So to generate the pie chart, what we need, only frequency value. So we'll call this frequency. So we need this column only, and then we'll call this pi function. So if you see here, our pie chart is done, okay, but it is not that much information is not there, okay, and the colors are also some light colors are there, okay. So we'll modify this pie chart. So how we will do that? So let's first add some labels to it, okay. So this 1 2 3 4 5 doesn't showing any information, okay. So we'll add the label, and under this function we have the label argument where the value should be var1. What exactly var1 is? Var1 is this document type, article, conference paper, editorial and all, okay. Then the main is the title of the graph. So I'm just giving the pie chart. Then the color. So here I am using the rainbow platelets, okay. You can give any like 6 colors, 7 colors, whatever the color you want to have. And under this, what I am calling here is the enrow df doc type. So what this enrow is? So enrow is basically selecting the colors from the rainbow based on the number of documents we have, okay. So here we have how many number of document type? We have 5. So 5 rainbow color will be selected, okay. And this sex 0.5 the size of those label, okay. So if I call this, it is done. So we can see that article, conference paper, review, book chapter, editorial is there. We can also this size is too small, we can just simply put to 1, okay. So we can easily see that these many documents are published as article, and these many conference paper, then editorial, book chapter and review. So also you will notice here that how this thing is done, how this pie chart is created, okay, whether it's clockwise or anti-clockwise. For this, it also has one argument, that clockwise operations. So if we give this clockwise to true, let's see what will happen. So now it is done like this. So it has other many arguments which you can explore, and let us know in the discussion forum that what all arguments of pi you have used, and whatever your experience is, that we should use those kind of argument necessarily for creating a beautiful pie chart. Okay, we can export this file. Let us see, we'll export this file only, and we can give the size and whatever the format we want, we can save it. Another beautiful feature here in R Studio is that you can export the plot wise. Okay, so say for example you have created 5-10 plots of the same data. Okay, and after that you want to have only one or two. Okay, so you can click here either this way or this way. Okay, so if you want this pie chart, you just export it, or maybe you want this, you just click here, save as image, so this will be exported. Okay, so our document type is done. So next we will move to the our second analysis, which is highly cited publication. To calculate the highly cited publication, what all things we need? We need the citations mainly, and addition to that we can take just title data also. Okay, so that we can easily visualize that this particular document is the cited by these number times. Okay, so first we will create a data frame that have these two columns. One is title and another is citations, and I am naming it as a df case to C, and this is a data frame, and this I already discussed that why I am putting this title, because data frame will give the long column name based on this. So that is why I am putting here title equal to this and citations. So sometime when you will use this kind of names like what I have used citation, so it will automatically display that there is a function exist with small c. Okay, so sometime confusion can happen. Okay, so try to avoid this kind of column name. But if you can remember this, that the word with capital C is my column name and the word with small c is the function in R, so it is almost okay. Okay, so I am using this my column name, and then this is my column name of title, and I am creating this for our, and I just use this way and I run this. So my data is created, just I view it. So this is our data set. So if you see here, some NAs are also there, but if you go down, title of the publications are there and then citations are there. Okay, now what we have to do, we have to sort these publications based on the citations. Our only thing what we need to do is that we need to sort based on this citations basis. Okay, so the citation will be our criteria, that whatever the paper has been received the highest number of citation, that should be on top. Okay, so we want to sort our data set in decreasing order. So we'll call this, and now we will see our sorted data. So it is sorted down. So now we want to extract only top 10 highly cited publication of the professor. So how we will do that? We will use the head function. This is our data set where we have the sorted data set, and under this sorted data set we will say that give us the top 10 value. This is our head function. So I will just call it like this. And now if I see our top 10, this is our sorted data set where we have title and citations, and here we have the top 10 publication with highest number of citations. Okay, so now say for example we want to have all those publications which have received at least 100 citations. That means we want to have the publication which have received 100 or more than 100, maybe 101, 102 or maybe 200. Okay, how we will do that? So this is your practice assignment. You just try based on like the lecture we have discussed yesterday, and let us know in the discussion forum that how you have calculated the publications which have received at least 100 citations. Okay, let's move to our third analysis, which is topic modeling. So here we want to extract the topics from the publications. So how we will do that? We will use the LDA approach we have discussed in the text mining week. These many libraries we required for doing that. We'll run this, and also ggplot2 for plotting that topics and those words score. In topic modeling, what first thing we do? We have already imported the data. After importing the data, we go with attaching the title and abstract, because we have get the data in text in mainly in title and abstract. We are not taking up the full PDF. We will attach those title, and this is our abstract. So our original data set is DF case 2. If we see here, so this is our data set 805 publication. So we are going with title and then abstract. Okay, these two columns. We'll take these two column and make it as a single column where we have the title and abstract together. Okay, so how we will do that? We will use this paste function, and if I do like this, my object is created where I have the title and abstract, and after that I have discussed that we'll change the column name because it will give the long column name to us. Okay, so we'll make it change of the column name. So now our data set is ready with title and abstract in single column. Now we'll see our first value. This is there. So this was our title, and then this the abstract is there. So this is the title. We have the title here, and then this is the abstract. Start with the integration. If you remember, when I was discussing about the text mining of our journal of cleaner production, we have this particular string in the end, and we have discussed that this we will be removing. But here all publications are not from elsewhere. Okay, it can have multiple other pattern. So first we need to see that what exactly our data set is. So let us just first go through our data set. So this is the first abstract where we found that okay, this we have to remove. Then maybe we go to the 10th abstract. There we have some different thing. Okay, we don't have elsewhere. We have this copyright 2023 hydrogen energy publication LLC. If we go to 13, here we have IEEE. After this dot we have IEEE only. Then if we go to 17, so here we have after copyright 2007 to 2012 IEEE. If you see here, what exactly the pattern is, earlier what we have used that after that copyright symbol, anything like elsewhere limited, we have made that our pattern and we have removed it. Okay, now if you have noticed here that in three of the abstract, we can see one kind of pattern is that if we could locate a copyright symbol and after that whatever thing is available, just remove it. Okay, so if you see this particular abstract here, after C, this is the thing what we have to remove. Then if you see in this, after this copyright symbol, this can be removed. Then here also. Okay, so one thing we have easily found that okay, we have to make a pattern in such a way that whatever the thing is coming after the symbol copyright, you remove it. Okay, that is so. So we can do like this. So this is our pattern. So this is the copyright symbol, and whatever thing is coming, just remove it. So using this, so it is removed. Now if we see in the next one also, it is removed. Now we'll see here also it is removed. Now another pattern we need to find out is in this. Okay, here what exactly is that? After the last period symbol there is some word is there. Okay, so this copyright symbol is not there, so we don't know, because we have the 800 publications are there, and each abstract sometimes other publishers details can be there. Okay, so what we will do is that whatever the thing is in the last, we will remove it. Okay, so we will create a pattern, and now if I do like this, so that IEEE is removed. So our combined pattern is either anything you find related to copyright symbol, and after that whatever you find you remove it, or the last word. Okay, this IEEE or anything is there. Okay, so we'll use this pattern, and this is the pipe symbol. This pipe symbol what exactly represent? Or either this or this. So we'll create this pattern. This is my pet. So now if I call this, that is removed, and for 13 also it is removed. Okay, so it is working absolutely fine. So this is the only thing which you need to remember, like whenever you are extracting the data from different source, so it may have different, like these kind of text are there. Okay, other than that we have already created our one function, so we have spent a huge amount of time for creating this function. So I'll just simply copy that function to here and use it. So what exactly change I am doing here is that I am changing my pattern. Okay, so this pattern may vary from your study. Okay, so you need to know, like if you don't have this kind of pattern in your data set and something else, so you need to change that. Okay, and also like if you find some other pattern other than this, please discuss in the discussion forum, so that we can have that what all kind of patterns can be in this academic data set we have. Okay, so this is our function. So this is the exactly the same function what we have created in week 9 lectures. So I'll just simply run this. My data is this, where my column is there. My data is this, where I have title and abstract. So I'll just call this function, and I'll assign to this another object. Now we'll make the corpus. So for corpus, we need to call this clean data. We'll call this function corpus, and we'll run this. Our corpus is created. So now we will create the document term matrix. So to create a document term matrix, we'll use the function document term matrix. And if you want to see that what exactly that document term matrix is, we can use that question mark. So I'm just keeping this, and then we can create our document term matrix. Now we want to see that what exactly this document term matrix is. So it shows that there are like 805 documents are there, and then terms are 5234. Now here this is a practice assignment for you. In the discussion forum, please discuss about what exactly this sparsity 99% represent. Okay, we have discussed when we were discussing about the text mining in the week 9. Okay, so just let us know that what you have understand with sparsity 99%, and what exactly that word maximal term length 27 is. Okay, so now we can see the top words. So to see the top words, we'll call like this. So these are the top words. So if you see here that this whole code I have copied from the what we have discussed in the lecture week 9. Okay, so this is like whenever you do by this way, you this is a one time task. Okay, if you have a understanding on this, that how you have created the code, then you can use multiple times for multiple analysis. Okay, only things you have to change those names based on your requirement. Okay, now you can save these top 50 words in external file. So I just changed to our authwards, and if I do like this file is created. We can see in documents. So these are the top 50 words are there. Okay. So now we'll do the topic modeling. So for doing the topic modeling, I am again selecting the 5 topics. I am just calling the 5 number of topics, and I'll be calling the LDA function of the package topic models. So this is my function name. Then this is our document term matrix. Then this is the K is the number of topics. Then give sampling, and then our seed is 1 2 3 4. Okay. I run like this. Our LDA model is done. Now we can see our topics. Okay. Then we can see the maximum value of, say for example, we want to see maximum value among these. Okay. So we can do like this. And if we can sort this value in decreasing order. So this is the value what we have got it from here, the maximum value. So maximum value of beta score for that one term. Okay. So now based on this we can create the topic words. Let's make it as a data frame topic export, and we run this. And now if we see here, so these are our 5 topics and corresponding 10 words are there. Okay. This we can export it. So like I'll just name it as topic export, and maybe AU. So this is done. Now if I open it, our documents, okay. So these are the 5 topics are there, and these are the 10 words corresponding, and based on this we can now get to know that what exactly that topic 1 is, topic 2 is. Okay. Now we want to have the top terms of that particular topic. We will call this library deployer for this process, and we'll call this based on beta score, and we see our top AU terms. Okay. For topic 1, we can see that here these are the words are there based on their beta score. Okay. Here we have the topic and the corresponding words, but we want to have this beta score also. Okay. What word exactly have the highest beta score? Okay. So this information we have. Now we can visualize it, this information, that this is the topic. For this topic these are the 10 words are there, and this is the beta score. Okay. What plot we will do? We'll do the bar plot. To create the bar plot, I will reuse the code we have created in our previous lectures. We have seen that we can create 5 plot one by one, or all those 5 plot in a single plot also. What I will do here is that I'll create all those 5 plot one by one, and then I left over this to you as a practice, that you create all those 5 plots in a single plot for this particular data set, and let us know in the discussion forum that what exactly plot you have plotted. Okay. How we will plot this bar plot of topics and terms as per the beta score? So we'll call the beta score of our terms, and then these exactly the terms, okay, and this is the title of our plot, okay. So if I run this, so for topic 1 that is done. So the terms like power, control, grid have more beta score compared to other words, and similarly for topic 2 if we see here. So if we see the topic 2 bar plot, there is not much difference in the beta score between the terms. Like if we see for topic 3, yes, for in topic 3 we have this word energy, which is having the high beta score compared to other terms. Other terms have their like close beta score, okay. Then we go for topic 4. Similar kind of things are for topic 4 also, and for topic 5. Yes, so in topic 5 also one word algorithm is having the high beta score, but other words are having like similar beta score, okay. So this is how you can plot your topic and terms bar plot. Here we have discussed about the topic modeling of the publication of the professor. So we have done the topic modeling of 805. So now as a practice you just give a try that how exactly this topic can be labeled to those publications, okay. So we have discussed this already in our previous lecture. This is all about this case study of an author. In this particular lecture I have discussed about the 3 analysis. At the first I have discussed about this document type, what kind of documents have been published by the author. Then we have discussed about the citations, that highly cited publication, what all those top 10 publications are there which are highly cited. And I have given this as a practice assignment to you, that you will identify that all those publications which are like having at least 100 citation. And in the last we have discussed about the topic modeling on these 805 publications. So this is all about the case study of an author. We'll see you in the next lectures, where we will be discussing about the case study of a journal and an institution. Thank you.